Good morning. Today we are going to see the third chapter in chemistry. The chapter is classification of elements and periodicity in properties. Now in this chapter you will learn about the periodic table in detail, and also you will learn properties, that is periodicity in properties of elements. Now you know that the modern periodic table that we follow now, or it is also called long form of periodic table, is given by Henry Moseley. And Henry Moseley formulated the modern periodic law. Modern periodic law. Now, the periodic law, the modern periodic law states that the properties of the elements are periodic function of their atomic numbers. Means we know that in the present or the modern periodic table, the elements are arranged in increasing order of their atomic number. Now, let us see what are groups and periods in a periodic table. So, first we are going to discuss about periods in a periodic table. Now, this is the modern periodic table, and you can see the horizontal rows are called periods in the periodic table, and we have 7 periods in a periodic table, and the numbers are written here. The 7 periods in a periodic table, and each period is given n value, or we can say n value denotes period number. That is, n is equal to 1. N is our principal quantum number. N is equal to 1 denotes period number 1, n equal to 2 denotes period number 2, n equal to 3 denotes period number 3, like that. So we have total 7 periods or 7 horizontal rows in a periodic table. Now let's study in detail about each period, the elements present, the number of elements present, the orbitals that are getting filled in each period, the name of the period if it has, etc. So let's come to the first period of the periodic table. So first period, for first period we have n is equal to 1, and we know that the 2 elements present in first period are hydrogen, this is hydrogen, and helium. This is the first period present in elements present in first period of the periodic table. So only 2 elements in the first period, they are hydrogen and helium, and the oneness orbital gets filled in these elements. See, n is equal to 1. For oneness orbital, n is equal to 1. So in first period elements, oneness orbital gets filled. So you know the electronic configuration of hydrogen. Hydrogen atomic number is 1. So hydrogen, that one electron enters into lowest energy level, that is oneness. So the electronic configuration of hydrogen is 1s1. Next comes helium with atomic number 2, means one more electron has to be added. And we know an orbital can place maximum 2 electrons. So again, that second electron in helium will enter 1s orbital. So the configuration is 1s2. Now 1s orbital is completely filled. Okay, that is first period. Now let's come to the second period. In second period, for second period we have n is equal to 2. Now second period we have 2s and 2p orbital getting filled. So the orbitals getting filled in second period are 2s and 2p. Now 2s means we have we can have 2 electrons in 2s orbital, and 2p, we have 3 p orbitals, px, py, pz. So here it is 2p, so we have 2px, 2py, 2pz. So total number of electrons that can be accommodated in 2p orbital is 6. So 6 plus 2 electrons in 2s orbital means 8 electrons in total, which means there are 8 elements in second period. Now look at the periodic table. We have 8 elements. This is period number 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Total 8 elements. And you can see after 1s getting filled with helium, lithium has atomic number 3 and the 2s orbital starts filling with lithium. Then next element is beryllium, 2s gets completely filled. It is 2s2. Now next we have boron with atomic number 5. So the next electron will enter into 2p orbital. So the configuration of boron is 1s2, 2s2, 2p1. Then comes carbon, each p orbital gets filled, and with neon the p orbital gets completely filled, and we know the configuration of neon is 1s2, 2s2, 2p6. Okay, so here we have 8 elements, and the element starts with lithium and it ends with neon. So you should know the names of first and last element of each period. Lithium to neon is in second period of the periodic table. Now next comes third period of the table. So third period. And in third period we have n is equal to 3. And in third period we have 3s, 3p and 3d. These are the orbitals with n is equal to 3. 3s, 3p, 3d. But in third period we have only 3s and 3p orbitals getting filled, not 3d orbitals. So third period we have 3s and 3p orbitals getting filled. Now why 3d is not filled after 3p? Because we know when we arrange the orbitals in increasing order of their energy, 3d comes only after filling of 4s, or we can say 3d is of higher energy level than 4s. So after 3p it is 4s orbital that gets filled. Only after 4s orbital gets filled, 3d orbitals fill. So in third period we don't have the 3d orbitals getting filled, we have only 3s and 3p. And you know 3s can accommodate 2 electrons and 3p can accommodate 6 electrons. So total we have 8 electrons that can enter into 3s and 3p orbital. So again in third period we have how many elements? 8 elements. So again 8 elements in third period. Now look at the periodic table. Third period we have 8 elements starting with sodium. And sodium we know we write the configuration of neon, and then the valence electron in sodium will enter into 3s orbital. So the configuration of sodium is neon 3s1. Now after sodium comes magnesium. With magnesium 3s orbital is completely filled. Then comes aluminium. Aluminium we have 3p orbital starts filling. So here the configuration of aluminium will be neon 3s2 3p1. Then we have 3p2, 3p3, 3p4, 3p5, and with argon 3p orbital gets completely filled. So you can see the elements in third period starts with sodium and ends with the noble gas argon, and total we have 8 elements in third period. So third period we have 8 elements, and the elements start from sodium and ends with argon, sodium to argon. Okay, now next let's see period number 4. That is fourth period. In fourth period we have n is equal to 4. Now in fourth period, first 4s orbital gets filled. So we have in fourth period 4s orbital getting filled first. After 4s comes 3d orbital. After 3d comes 4p orbitals getting filled. So these are the 3 orbitals that get filled in fourth period, that is 4s, 3d and 4p. Now s can accommodate 2 electrons, 3d can accommodate 10 electrons because we have 5 d orbitals. So 5 into 2, 10 electrons, and 4p can accommodate total 6 electrons. So 10 plus 6 plus 2, we get 18 electrons, which means there are 18 elements in period number 4. So how many elements in period number 4? 18 elements. Now look at the periodic table. Period number 4, we have from potassium, atomic number 19. The symbol of potassium is K. Ka was used first, that is kalium, but K is the symbol of potassium, it is not Ka. From atomic number 19, we have 19, 20 calcium. So potassium and calcium 4s orbital is getting filled. Then we know in fourth period 3d orbital gets filled, that is from atomic number 21 to atomic number 30. 10 elements, because you know 3d orbital can accommodate 10 electrons. So this scandium has D1, 3d1, titanium 3d2, 3d3 like that, and finally with zinc the 3d orbital gets completely filled. So when you come to zinc, the configuration of zinc is the noble gas taken by fourth period is the third period noble gas configuration, that is argon. So what will be the configuration of zinc? Argon 4s2 3d10, and I told you 3d is the inner d orbital. So when you write the configuration, you will write argon 3d10 4s2. Now after 3d we have 4p orbitals and 6 elements whose 4p orbitals are filled, that is gallium, germanium, arsenic, selenium, bromine and krypton. So fourth period ends with the noble gas krypton. So we have total 18 elements, and we have the 4s, 3d and 4p orbitals getting filled in fourth period, and the elements are from potassium, to the noble gas krypton. Now here these 10 elements, that is from scandium to zinc, whose 3d orbitals are getting filled, they have a name. They are called 3d series. So scandium to zinc, whose 3d orbitals are getting filled, they are known as 3d series, or they are our transition elements, and 3d series are called first transition series. So scandium to zinc, whose 3d orbitals are called first transition series, or they are called 3d series because their 3d orbitals are getting filled. So this is about period number 4. Now let's move to period number 5. Now in period number 5, or fifth period, we have n is equal to 5, and in fifth period the orbitals that get filled are 5s. Now after 5s we have 4d orbitals getting filled, so 4d, and after 4d we have 5p orbitals getting filled. So again you can see here total how many elements can be placed. 5s can place 2 electrons, 4d 10 and 5p 6. So total 10 plus 6 plus 2, again we have 18 elements in fifth period. 18 elements. Now look at the periodic table. Fifth period we have the first element rubidium, strontium. Now rubidium and strontium, their 5s orbital gets completely filled. Rubidium has configuration 5s1, strontium 5s2. And which noble gas configuration they take? Krypton. So what will be the configuration of rubidium? It will be krypton 5s1. Strontium will be krypton 5s2. Then after 5s, 4d orbitals get filled. Now you can see in period number 4, it was 3d orbitals that got filled. It is n minus 1. N minus 1 d orbital. N minus 1 d orbital. Now check for the fourth period. For fourth period, n is equal to 4. So we have 4 minus 1, which is equal to 3. Or we can say 3d orbitals are filled in fourth period. So in fifth period, it will be n minus 1, means 5 minus 1, 4d orbitals will get filled. So here you can see which is the element whose 4d will start filling. Yttrium, Yttrium, yttrium to cadmium. We have 10 elements whose 4d orbitals are filled. Now with cadmium, the 4d will get completely filled. Now after 4d, we have 5p orbital getting filled. So 5p will begin with indium and it ends with the noble gas xenon. So in fifth period, we have total 18 elements beginning with rubidium and ending with the noble gas xenon. Fifth period, we have elements from rubidium to xenon. And the elements, that is from yttrium to cadmium, yttrium symbol is Y, yttrium to cadmium Cd, whose 4d orbitals are getting filled. They are known as 4d series or second transition series. Series or second transition series. So this is about period number 5. Now next, let's see about period number 6. Now we have our sixth period. And in sixth period, we know n is equal to 6. And in sixth period, the orbitals that get filled are 6s. Now, after 6s, here we have f orbitals getting filled. So, you know that f orbitals begins with n is equal to 4. So, here we have 4f orbital getting filled after 6s. Now comes d orbital. Which d orbital will get filled in sixth period? N minus 2. So, n minus 1 d. So, 6 minus 1 d, it will be 5d orbital. So, after 4f comes 5d orbitals. Now, the extreme right side we have 6p orbitals getting filled. So, tell me how many elements can be placed in period number 6. 6s can place 2, 4f, total number of electrons that can be placed in f orbital is 14, because we have how many f orbitals? 7 f orbitals. So 7 into 2, 14. 5d can place 10 electrons and 6p can place 6 electrons. So total we have 2 plus 14 plus 10 plus 6, that is 32 elements. So in sixth period we had 32 elements. And which are the orbitals getting filled in sixth period? 6s, 4f, 5d and 6p. Now let's come to the periodic table. Look at the sixth period. We have the element cesium first, cesium. And cesium, after that barium, whose 6s orbital is filled. Now after 6s we have 4f orbital getting filled. Now this is also inner f orbital, or we can say here it is n minus 2 f orbital that gets filled. Now you substitute for n. N we have 6th period, n is equal to 6. So what is 6 minus 2? 4. So in 6th period we have 4f orbital getting filled. So we have here, if you look at the periodic table, you can see barium atomic number is 56. After 56 we have 57 here, lanthanum. Okay, now lanthanum is here. Now the next 14 elements following lanthanum, their 4f orbitals are getting filled, that is, and these elements you can see here, it's written 57 to 71, that is atomic number. 57 is actually placed here, lanthanum. 58, that is from cerium to lutetium. Cerium atomic number is 58, lutetium is 71. You count how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. 14 elements means f orbital is getting filled, each f orbital. Now these 14 elements whose 4f orbitals are getting filled are placed at the bottom of the periodic table. Okay, and we call these elements, that is element number 58 is cerium to lutetium, as inner transition series or 4f series. So we can call the elements from cerium to lutetium, that is atomic number 58 to 71, 14 elements. They are placed at the bottom of the periodic table and their 4f orbitals are getting filled. They are called 4f inner transition series. Or they are also called first inner transition series. Now, after atomic number 71, if you look at the periodic table, you can see 72 is hafnium, which orbital? D orbital, and which D orbital? In the 4th period we had 3D, next period 4D, now in 6th period we have 5D orbital getting filled. So hafnium to the last element, that is mercury. With mercury, the D orbital, that is 5D orbital, gets completely filled. And you can call these elements, you can say from lanthanum onwards, from lanthanum to mercury, the elements from lanthanum to mercury. Lanthanum, La, to mercury, they are known as the 5D series, 5D transition series, or 1, 2, and this is the third transition series. And which orbital is getting filled from lanthanum to mercury? It is the 5D orbital that gets filled. Now after 5D orbitals, from after mercury, we have the 6p orbital getting filled, that is from thallium to radon. 6p orbitals get filled. So if you look at period number 6, we have the first element cesium and the last element radon. So the element in 6th period is from cesium to the noble gas radon, total 32 elements. So 6th period we have our first inner transition series, and 4f orbital is getting filled in first inner transition series. Now next we have the last period element, that is period number 7. 7th period, we have 7th period, n is equal to 7. Now you can say in 7th period, which are the elements that get filled, or the orbitals that get filled in 7th period is, first we have 7s. Look at the periodic table, 7s. We have francium and radium. 7s2 gets completed with radium. Now after atomic number 88, we have atomic number 89, actinium. After 89, 90 to 103, 14 elements following actinium. And which orbital gets filled in them? 5f orbitals. So after 7s we have 5f orbital getting filled. Now after 5f orbitals, again we come back to element number 104 to 112, that is rutherfordium to copernicium, or we can start from actinium to copernicium. Which orbital gets filled? After 5d we have 6d orbitals getting filled. Then after that we have 6 elements whose 7p orbital gets filled. So total how many elements in 7th period? Again 32 elements. So you can say that the elements from thorium to lawrencium, Lr, 14 elements. Which orbital is getting filled in them? The 5f orbital. 5f orbital is getting filled. So they are called 5f series. 5f inner transition series, or you can say second inner transition series. Now after this we have from actinium to copernicium. So actinium symbol is AC, to copernicium Cn, whose 6d orbital is getting filled. They are known as 6d series or 4th transition series. Now after copernicium we have the 7p orbital getting filled, and you can see the symbol of the element written as UUT, UUQ, UUP, etc. There is no name given to these elements. So that you will learn after in the next video what is this UUT, UUQ and all. Okay. So we have 6 elements. So you can see in the modern periodic table we have 118 elements available. Okay. And again you can see that there are 4 transition series in the periodic table. Which are the 4 transition series? 3D, 4D, 5D and 6D series. And the 3D series, the first transition series is in which period of the periodic table? 4th period. Then next, second transition is in 5th period, third is in 6th period and 4th transition series is in 7th period. Now we have 2 inner transition series, and the inner transition series are placed at the bottom of the periodic table, and we have 2 inner transition series. They are called the 4f or first inner transition series and 5f or second inner transition series, because their 4f and 5f orbitals are getting filled. Or we can say, what do you mean by the first inner transition series? The 14 elements which follows lanthanum, whose 4f orbitals are getting filled, are known as 4f inner transition series. And what do you mean by the 5f inner transition series? The 14 elements that follow actinium, whose 5f orbitals are getting filled, are called second inner transition series. Now you can also call the elements in the first inner transition series, that is from cerium to lutetium, they can be called as lanthanoids. Lanthanoids or lanthanums, lanthanoids. Okay, they can also be called as lanthanoids. Now, or lanthanides. And the elements of second inner transition series can be called actinoids or actinides. The first inner transition series are the elements that follow lanthanum, and the second inner transition series are the elements that follow actinium. So they are called actinoids or actinides. So this is about the period, 7 periods in the periodic table. Now let's come to the groups in the periodic table. Now groups means, you can see the vertical columns in the periodic table are called groups, and you can see the group numbers are written on the top. we have 1A, 2A. This is the old version of periodic table. Actually, this is 1, group number 2, 3, 4, 5, 6. So 1 and 2, we have s orbitals getting filled. Then from 3 to 12, we have our transition elements. And from 13 to 18, we have our elements whose p orbitals are getting filled. So you can see in the periodic table we have 18 groups in total, 18 groups. Now the transition elements are from group number 3 to group number 12. And you look at the inner transition series, they actually belong to group number 3 because from 3 they are taken and placed at the bottom of the periodic table. So the vertical columns, 18 vertical columns in a group are called, in a periodic table are called groups. And you can see when you move along each element in a group, they have same outer electronic configuration. Look at group number 1. In group number 1, we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. You can see their N value is different. For hydrogen, N is equal to 1, lithium 2, sodium 3, potassium 4, rubidium 5, like that. But they have same number of valence electron. All these elements in group 1 has 1 electron in their s orbital. Same way, group 2, the number of valence electrons is 2. Group number 13, this is 13, boron, aluminium, gallium, indium, thallium. We have 3 electrons in the valence shell. 14 has 4, 15, 5, 16, 6, 17, 7, 18, 8 valence electrons. So this is about the groups. Thank you.